Hello everyone, this is Bradley. Today this is a voice recording to make a fake splashy effect in geometrynodes. As you may know that I'm not usually a fan of the simulation methods, and these methods is really simple. The technique is extremely old. I want to share this because I used this technique recently and I try to share this method. So let's start. So here in Blender, as always, I'm going to use the preset which you can download for free from the link in the description. So let's start with a curved circle. And basically the idea is just to use volume in geometry nodes. And we need curve to guide the points or particles to move. So I'm going to point instance, and I can use an arc, or you can construct your own geometry. So right now this arc looks kind of very weird. One reason is it's too big. We can turn off the angle. Something like this. Yeah, I think this is fine. But you also notice that this arc is a single element. It cannot have variation unless you do the repeat zone in 4.0. So this is a very interesting question. I may not want to do this setup. So let's start with curve linear. I feel like 80% of my tutorial is actually about curve linear. So now if I start with it, you see it's not aligned, so we do not center it, and we take an alignment on splice. We take this rotation. So now everything is properly aligned, and we give some, not this one. So this is the axis. Okay, so now we have this kind of a splash effect. But obviously this is not what I'm looking for. What I want is to realize the instance. And let's set some vector rotate. So we take set position. So we need a position attribute. And we vector rotate here. Here basically every rotation should be done on its local axis. So this turns to be a little bit tricky, I think, because how do I know the axis? Which axis am I using? First of all, I think I'm using the tangent and the normal from our initial points. So can I just do the cross products? Let's capture attributes. This may be a very weird way of doing. Anyway, just to give you kind of idea, if we directly use this spline parameter to check the angle, then it looks like this because we're rotating on this z-axis. But you have to be kind of local so that it does not look something like this. Okay. And can we use the position? Oh, this is just any. No, it does not work. Forget about that. This is too weird. But we need to start with the rotation, correct? So we take the spline info, not this spline info. We need an attribute spline to get the start position. Okay, so now it looks like this because everything is rotating relatively to start, but it's still not local rotation. But anyway, so we are going to try to do that. We take a tangent, a curve tangent. Jesus Christ. We take a curve tangent and we take a curve normal. This is actually going to be very similar to what we do here with alignments, because we are getting tangent and normal, but this time we're trying to get a cross product so that it's an axis. So if I have normal here, if I have tangent here, the cross product is points 90 degree shoot out from the plane. This kind of idea. And it's not working. No, not at all. How come it doesn't work? Maybe it just shouldn't. So if I use the tangent, oh, the tangent works. Okay, then I do not need. If I do not capture it, then it doesn't work. But anyway, you get a kind of idea. So now it looks like kind of a splash, and the benefit of using this setup compared to the arc previously is that we can change the magnitude of it. So spline parameter goes from 0 to 1 from the start to the end of a curve, and we can take a random value to control it. And now everything becomes ugly because we are assigning a random value for every point. We evaluate on domain so that the value will be the same for every spline. So now we have variations of it. We just decrease the magnitude. Actually, I can even rotate it. Perhaps we can add a random value to this as well. So we combine X, Y, Z. And let's add 65, negative 65. So we have double random value, whatever kind of sort of things. So we can have random value of more bendings, and just remember to get a different seeds. Okay, so something like this. And if you want, you can increase the amount of resolutions, so it becomes very chaotic, and something like that. And instead of using randomness, you can also use a noise texture. Or sometimes I made that noise 3D. They're the same, does not really matter. So that from spline to spline, they have a more regular relation. They have a more continuous relationship instead of this complete chaos. Okay. And here we notice there are some spline which is off the place. We can delete them if you want. So let's delete some of them. So let's say I have a delete geometry. I don't really like this node because sometimes it would by default delete everything. It's not easy to really visualize stuff. But anyway, so if the position value we separate x, y, z, if z is less than, or let's say less than 0.1, then it will be deleted. Then you will find that the initial point will also be deleted. So we take and a second condition that spline parameter should be greater than 0.5, so that we only delete these points when they're at second half of the segments and lower than the threshold. Okay, so something like this. And finally, the major part of this entire setup is to actually array splines. I think I made mistakes in recent commit on this node. because now everything just looks like a curve, but it's actually points. It is supposed to be points. So we take a curve points preview. I think I'm going to fix that, so you do not need to do this process. And let's add a count. So we have this curve points. Okay, and we're driving these curve points. Set curve radius. And we take spline parameters so that we have a radius output, which you can see. Okay, this is too bad. We can remap 0 to 1 just to give you an idea how it looks like. Okay, we reverse 0 to 1. So now this is how this splash looks like. Okay, and by manipulating the offsets, actually we are running this curve or these points across. Okay, so by default this is looping start and at the end, but if we do not loop it, then by manipulating this offset we have this shooting out effect. Okay, so this is what I'm trying to do. So we take points to volume, and we take a volume to mesh. It might be possible that we use the radius attribute in this case, because we're assigning the radius for these points, and we get this result. If you do not have this, you can also use the radius here. It will essentially do the same thing. Not really. Okay, because I remapped it. Fine. So you see, they're the same. So once we do that, you may bump up this voxel amount. You may increase the radius of the points. You may smooth everything out with the smooth position. This is actually very important because by smoothing it, you get this effect. And you notice that it will be better if you have some thickness at the end. So actually now it looks more like kind of coral whatever stuff. So to continue this entire setup, we basically just start and something like this. And then now we realize that everything is just being separated too much. And this is a little bit confusion. That's why sometimes we need a noise. So this actually distinguishes between noise texture and the random value node. We have noise texture and we have random value. Random value will be different from point to point. Noise texture will map a noise onto 3D space. So if you want to have a more continuous result, you want to use the noise texture instead and the noise 3D. Okay. So what do we do now? Can I just use this value? Okay, and I increase the scale. It becomes like this now. If I change this mid level, now it becomes a flowery, whatever. And then I decrease the scale. Okay, and if I turn off this, so let's add another noise 3D. This time we rotate it, but I'm going to change the seed. So I'm going to make it like I don't know why this is the value, but I actually don't know why this is the value. Doesn't seem to be right, but at least we get something. And you can increase the frequency if you want. You can increase the frequency if you want. So we finally get something like this. You can make it more noisy, 15, 20, or increase the amplitude. These are all options. 25, perhaps this. Make a 3, 4, 5. I don't usually go this much frequency in real life because the actual noise looks to be very ugly, but it works now. Okay, so I think we can continue, or actually at some point we are basically finished. So you just crank up the values, make sure it didn't crash your computer, and then we basically just animate it. And make sure that we have a value at the end. Probably. And we can decrease the count too, so that there will be less connection from point to point. Or what we can do is to delete some points, so that we are creating a kind of interval, random value. We take a boolean, so that we're deleting some points at the end. This probability should increase as this span parameter goes, so that we have a more kind of splashy results. This is actually a genius idea. Jesus Christ. And for some reason the initial, oh yes, because the initial parts, the probability is 0, but even the base is not being affected at all. I guess it's simply because of the density of this many whatever stuff. So finally we just animate this splash stuff. Okay, and you realize that's actually we should clamp at 0. So let's just take a controller. This is just to import the keyframe, because I personally do not like keyframe in node editor due to many reasons. I want to allocate all these kind of values, -10 to somewhere that's easily accessible. Oh, I'm not, I was keyframing the plane or whatever other stuff. Yes. So we keyframe it. So we start from 0, -10, and then we can make it circular. And if I, what's the shortcut of it? I almost forgot. Yes, exponents. And now if I play it, so this is what we get. Now, actually pretty interesting. And one kind of benefit for this kind of volume thing is that it can be attached with other volume thing. For example, maybe I have a ground and I can put a volume to that as well. And I can even join this geometry. For example, maybe this is not a separate ground, but I have a grid, and just to make it 100, 100, and I join geometry. Before that, let's just keep a capture in case there's anything wrong with it. And we join geometry. I don't find anything. I need to 15. And you find that there's no radius for this grid. So we add the attribute together. So the plane, maybe just give it a value of 0.1, hopefully. 0.2. So yes, so we started with kind of grounds, whatever stuff, and then you see this kind of effect. And you can definitely increase the voxel amount and other things. Or I guess you can use these sides. Okay, this is too much. It'll probably crash my computer because I just really have too many vertices, whatever. But I think you get a kind of idea. And it was really just an experiment. Okay, so this isn't a real simulation. So you do not really need to play the animation, you can just see the final result and tweak your value until you find it's working. Let's just make it 5.5 and decrease the value. Everything is procedural. So I think now this is fine. Okay. So I'd say this is it. At last you can tweak all various stuff. So I hope you enjoy this video. I'll probably see you next time. Bye bye.